Hello everyone, very good afternoon. I welcome you all to this online webinar on design of box girder bridges with balanced cantilever methods using Midas Civil. In today's webinar, we will be discussing about the design of balanced cantilever method of construction, and we will have a modeling example with us. We will see that how we can actually model, analyze and design the balanced cantilever bridges or any other segmental bridges using Midas Civil. For the code of practice, we will be discussing about British standards as well as Eurocodes today. And just to give you a brief idea about the webinar today, so we have more than 500 registrations for today's webinar, and there are around 430 participants. And the webinar is being conducted for Singapore, Malaysia, Hong Kong, and Australia. So in today's webinar, we'll go through a presentation and we'll see the very basic concepts of the balanced cantilever bridge method of construction. We will see the complete design procedure. And before I begin the technical presentation, so if someone is not able to hear the sound, then please check the sound settings in GoToMeeting dialog box. So if you are not able to hear the sound, please check the sound settings in the GoToMeeting dialog box. And before I begin the presentation, before I go to the technical aspects of the presentation, I would just like to introduce about the promotional offer for Midas Civil that we are having these days. So the complete package for Midas Civil, it includes the time-dependent material properties as per CBFIP and Eurocode and Australian standards. And the moving load analysis is available as per British, Euro, Australian as well as American standards. Various types of seismic analysis are available and PSA design is also available. And using Midas Civil, you can actually perform the analysis and design of segmental bridges and various girder bridges. If you have PSC girder bridges, you have steel composite girder bridges, then those types of bridges can be done very easily in Midas. Along with that, if you have box culvert or frame bridges, then you can use Midas Civil. And even for cable stayed suspension and extra dose bridges, Midas Civil can be used very effectively. And the cost of the advanced version is discounted these days, and the discounted price is 13,500 USD, and there are some discounts available for the multiple purchases. Talking about the users of Midas Civil in Asia Pacific region, we have a lot of companies who are using Midas as their main analysis as well as design tool for the bridge structures. That includes AECOM, WSP Parson Brinkerhoff, T-Valin, LTA, YWL, SMEC and Oricon in various parts of Asia Pacific. And specifically in Malaysia, we have a lot of companies using Midas Civil. We have JKR and DBKL. Along with that, we have other companies like SMEC Malaysia, T-Valin Malaysia, HSS and PJSI. So most of them, they are using Midas Civil as their main bridge analysis and design tool. So now let's go back to our technical presentation and see that what we are actually going to discuss today. So today we will actually model a bridge. We'll model a curved balanced cantilever bridge, and the bridge will be tapered. So the profile of the bridge, the vertical as well as the horizontal alignment is mentioned on the slide now. So we'll actually take this example and we will see that how we can model the various parts of balanced cantilever bridge in Midas Civil. And meanwhile, if you have any questions, you can write down the questions in the questions window. I will be taking up all the questions at the end of the presentation. And The presentation and the demonstration is expected to be around 50 to 55 minutes. So I'll be taking all the questions after the presentation as well as the demonstration. So first we'll open this bridge in Midas and we'll see that how we can actually use the various features of Midas Civil in order to do our task quite easily. So I'll just move straight forward to Midas Civil and I'll open a new project. So since some of you might be new to Midas Civil, so I will just give a very brief introduction about the software first. So in the software we have the various menus and we can use any of the menus based on our convenience. So all the data we can input in the form of tables. So if you will see here in the table tab, we have node elements, properties, and even the results and loads. Everything is available in the form of tables. So these tables are compatible with Microsoft Excel. So we can copy paste the data from Microsoft Excel and we can create the model in Midas Civil using Microsoft Excel. And then we have this ribbon menu. In the ribbon menu, we have the various tabs starting from structures. In the structure, we have various wizards for bridges. So we have free cantilever method or the balanced cantilever method, and there are some other wizards for slab bridges, frame bridges, box culvert bridges, and movable scaffolding system bridges, and cable and suspension bridges. Along with that, we have two wizards for the girder bridges. So we have the wizard for steel composite bridge and the PC girder bridge. So the PC girder bridge will include U girder, I girder, and T girder bridges, which are normally used. And then the next element, the next tab is the node element tab. Then we have the properties tab, boundaries tab, loads tab, analysis tabs, and result and design tab. So we'll go through all these tabs one by one today and we will see that how we can actually utilize it. Along with this, we can call any of the functions by right-clicking in the work window. So if I right-click in the work window, I can call any of the features here and I can directly move to the analysis and design. So now here, in order to start my project, I will like to utilize these three coordinates which I have in Microsoft Excel. So the profile of my bridge is actually passing through 3 points and the coordinates of these 3 points are available with me in Microsoft Excel. So what I can do is I can just copy the data from Microsoft Excel, and once I move to Midas Civil, I can open the nodes table in Midas Civil and I can just press Ctrl V. As soon as I press Ctrl V, the data from Microsoft Excel is copied into Midas Civil and we can see the data in the works window as well. So I copied 3 nodes from Microsoft Excel and all these nodes are created as soon as I copied the data into Midas Civil. So now the next thing I want to do is I want to generate a curve which is actually joining all these 3 dots. So in order to do that, I'll use the option create line elements on curve. So here I can specify that how many divisions I want and I can generate a curve by clicking on these 3 points. So here you will see that as soon as I click on these 3 points, the curves are generated. And if you want to delete the free nodes can be deleted. So the curve is exactly passing through those 3 points and we have generated the curve easily using the generate line elements on curve option. So here we have this. So the next step that we want to do is we want to assign the material as well as the section properties. So we'll see that what kind of material and section is available in Midas Civil. So for the material, I will assign C45 and for the tendons, I can add another material. And similarly for the section, we can go to the properties and the section properties. So here in the program, we can add various section properties. So here if you see that the various section databases are available in Midas Civil. So if you choose any of the shapes, so for example, if you want to use a C-channel shape, then you can use various section databases, or else You can even create your own shape. You can input the dimensions and you can generate your own shape. The program will analyze and design for these shapes that you will specify. And similarly for the PSE shapes, you can specify any type of shape. So if you have a PSE section, you can have PSE 1 cell, 2 cell, PSE 3 cell, PSE n cell. It can be symmetric or it can be asymmetric. There is no limitation in that. So along with that, you can use PSE I cell, PSE I section, PSE T section, and various databases are also available. So you can use these various databases readily. And along with that, one of the very general type of section supported by Midas Civil is PSE value section. In PSE value section, you can actually generate any type of PSE section just by specifying the coordinates. And once you specify the coordinates, the program will generate the section for you and it will analyze and design the section as per the specified coordinates. So whatever section shape you have, you can actually use the section shape by specifying in the form of these coordinates. And the other option the program provides is that you can actually import any shape from AutoCAD DXF. So if you have a DXF file for the section shape, you can just import the DXF file into Midas Civil and you can use that particular section property and you can perform the analysis and design straightforward. So in order to save the time, what I will do is that I will just import the section properties from one of my previous models. So in my previous models, I have 3 sections, but I want to import only first 2 sections. So I've just selected first 2 sections. And as soon as I click OK, these sections will be imported into my model. So if you want to see the section properties, you can just right click and you can go to the properties and you can see the section properties. If you edit some section property, it will be reflected in the model directly. So here we have imported the 2 section properties from one of our previous projects. And now what we will do is that we will try to generate the tapered sections for our bridge. So let's see how we can generate the tapered sections. So the basic idea will be that we have generated 2 sections, the one with height around 4.65 meters and the another one with a lesser height. So we will ask the program to generate the tapered section from one section to the another. So in order to do that, we can just right click on the section, we can click on add and we can go to the tapered tab, and in the tapered tab we can choose PSE 1 cell and I want to generate 2 sections and I've specified that the J end of the section will be equal to the section ID 2 and the I end of the section will be equal to the section ID 1. So based on that, we can actually see the section in the graphic view and I'll click apply after entering the section name, and similarly I'll create the another section where the I section is the second section and the J section is the first section. So we have 4 sections with us. Now what I want to do is I want to assign these sections to my model. So I'll select the first 8 elements. Now in order to assign the elements, in order to assign the section to the elements, what I need to do is I just need to drag drop the section name from the works tree to the graphic view. So here you can see that as soon as I will release my click, the section will be assigned and we'll be able to see the section in the graphic view. And similarly, I'll assign the section to the third part of the bridge. And similarly to the middle part, I'll assign the taper to. Now, probably this is not what we expected. This is not what we actually want to achieve. So we want to make these 2 changes. So for example, consider this part. Now here what we want is that we want this part of the bridge to be equal to the dimensions on this part of the bridge, we want them to be equal to this particular section, and on the other part of the bridge, we want the dimensions to be equal to this part. So the basic idea is we want the tapering to be very smooth. And the second thing that we want is we want the offset to be changed to center top. So we can change the offsets very easily. We can just go to the offset and we can change the offset to center top. And similarly, we'll change the offset for the section 2 as well. So as soon as I change the offset for the second part of the bridge, the offset will be reflected in the works window, and I'll save the model with a particular name. Now in order to make the tapering smooth, what I can do is I can just select these elements and I can go to this option in the properties tab. There is an option called tapered section group, and here I can type a group name. So for example, I type group name group 1 and click on add. So the program has done the smooth tapering. Similarly, I'll do it for the group 2. Now here, one thing that you can see is that along with the smooth tapering, the program also provides you the option of polynomial or the linear tapering. So if you want to create some curve, then you can specify the exponent of the curve and the program will carry out the tapering based on that particular curve. So here I've specified the name group 2, and once I click on add, the program has generated the tapered section. Similarly, I'll do it for the group 3. So now here you can see that how easily we have carried out the tapering of the section. And now the next part that we want to do is we want to generate a pier. In order to do that, I would copy this node at a distance of 5 meters. So in order to copy the node, I can just go to translate and specify the distance that I want to copy this node by 5 meters. The node is copied, and similarly copy this particular node by 2 meters so that I can generate the supports, and copy this particular node by 1 meter. So using the translate node, I can do this quite easily. Now I want to generate the pier here. So what I can do is in the elements, there is an option called extrude elements, and I'll extrude this node to the line element, and for the section property, I'll import another section property. So from this model, I will import the property called pier, which is a box section. So we can readily use this property, and once we specify that the length of the pier will be 15 meters, so as soon as I click apply, the pier will be generated and we'll be able to see the pier. Now the next is I want to generate the boundary conditions. So for the boundary conditions, we can go to the boundary tab and we can define the supports. So I'll specify a fixed support here, and for the other nodes, I'll release dx, and for this particular node, I'll release dy and dz. And in order to join the supports by the deck, we can actually use the elastic links. So in elastic links, we can use rigid type of elastic links, and we can join the nodes quite easily using these elastic links. So here we have generated the model. So after this, we will see that how we can actually include construction sequence analysis in the model, and how we can actually include creep as well as shrinkage properties into our analysis model. So in order to define the creep and the shrinkage properties, we can go to the properties tab, and under the time dependent material, we have an option called creep shrinkage. Now the advantage of Midas Civil is that defining the creep and shrinkage for any type of material is quite simple and straightforward. So what we can do is, I prefer to use the units as Newton and mm here. So once I change the units, I'll go to creep shrinkage, add, and I can add the creep shrinkage as per CBFIP. There are 3 versions of CBFIP available, and we will use CBFIP 2010 for our usage. And along with that, European code is also available, so we can readily generate the creep shrinkage curve as well as the CBF according to CBFIP or the European curve. And Australian standards as well as New Zealand standards are also available. If you want to use AASHTO standard, that's also available. But for our example, we'll use CBFIP and specifying the characteristic compressive strength. And then I need to specify the notional size of the member. Now, we are using a tapered bridge. So the notional size of each and every section is going to be different. But we don't need to calculate the notional size for each and every member one by one. We can specify any notional size here, but for the analysis purpose, the program is going to calculate the notional size for each and every section by itself, so we don't need to worry about that aspect. So here, if you want to see the creep curve, you can just click on show results and you can see the creep curve, and similarly the shrinkage frame you can see in the form of a curve as well as in the form of an Excel. So once you complete this, you can click close and you can click OK. And similarly, we need to add the compressive strength. So we need to specify to the program that the compressive strength of the material is increasing as per which specified code. So here we will see that how we can do the creep as well as the shrinkage. So we are using the creep curve as per CBFIP 2010 and the shrinkage curve as per CBFIP 2010. And for the compressive strength, we'll use the same particular code, CBFIP 2010, and we'll specify FCK plus delta F. So please remember that this is not FCK, this is FCK plus delta F. So this number will be greater than 45. And once I click on redraw graph, I can see the development of shrinkage. I can see the development of compressive strength with time. So once it is done, we can click OK and click close. Now we need to link these two material properties with particular material. So we define two models, one for creep shrinkage and one for compressive strength. We will link these two models with the material selected, and in order to let the program calculate the notional size of the members, so what we can do is we can just select all the members, and as soon as we click on apply, the program will calculate the notional size of all the members. And if you want to see the notional size, you can go to the table of the notional size and you can see the notional size of all the different sections which is used. So here we have generated the model and we have specified the time dependent material properties, and we have linked the time dependent material properties with the various material definitions. Now the next thing that comes is the tendon. So let's see how we can actually generate the tendons in Midas Civil and what are the various options available for the definition of tendons in Midas Civil. So we'll use the various options which are available for the definition of the tendons. Meanwhile, I would just like to remind that if you have any questions, you can write down the questions in the questions window. We are getting a lot of questions in the questions window. I will be taking up all the questions at the end of the webinar. So if you have any question regarding the balanced cantilever bridges or Midas Civil, you can write down all the questions in the questions window. So let's move on. Now we will generate the tendons. We'll see that what are the various options that Midas Civil provides in order to generate the tendons quite easily and quite effectively. So the first and foremost thing that we need to do for tendons is that we should go to the loads, and in the temperature prestressed loads, we should define the tendon property. So in Midas Civil, we can actually use internal pre-tension tendons. So we can use pre-tension strands, and we can use post-tension tendons, and we can use the external post-tension tendons. So all these options are available, and today we are looking at internal post-tension tendons. So I'll generate a tendon profile for them, and for the material we'll use a particular material, and in order to specify the total area for the tendon, so we'll use this particular tendon area, and we have generated the tendon property. So now we have just generated the tendon property. We have not specified the location of the tendons, or we have not specified the profile of the tendons. In order to specify the profile of the tendons, what we can do is we can either click on the tendon profile and add the tendon profile one by one. So this is one of the most basic methods which is provided in Midas Civil. So in this dialog box, what we can do is we can generate the profile of the tendon one by one. We can type in the x coordinates and y coordinates, and similarly we can type in the x and z coordinates. So as we will generate the tendons, they will be reflected in the actual model, and we can link the tendons to various particular elements. So this is the most basic method of generation of the tendons. Along with that, the other methods available for tendon generation, they include importing the AutoCAD profile of the tendons. So if you have an AutoCAD profile of the tendon, you can just import the AutoCAD DXF file and you can use the tendons in that particular profile. So if you have the DXF file of the tendons, then you can just import the DXF file into Midas Civil, and you need not define the X, Y, and Z coordinates one by one. And along with that, the other option available for the generation of the tendons is there in the structure tab. So in the structure tab, if we go to PSC bridge and we click on the tendon template and we select the part of the bridge where we want to add the tendons. So here the program will allow us to add the tendons. So you can add the tendons of the various shapes and the program will let you do it. So you don't need to create any DXF file, you don't need to create any XYZ coordinates manually. You can just choose the tendon profile and the program will generate the tendons by itself. So the various methods are available for the generation of the tendons, and depending upon the data available, we can generate the tendon profile very easily. So we can generate the various tendon profiles. And talking about the tendon pre-stress load, we can specify the jacking stress in the form of force as well as in the form of stress. So we can apply the jacking force, and we can even do the sequential stressing. So for example, if we have one tendon and we want to stress that particular tendon in different stages, then we can apply the successive pre-tension load to that particular tendon in different stages. So this option is available, and we can generate the various construction stages. So let's see how we can actually generate the construction stages in Midas Civil and what are the various methods available for that. So for generation of the construction stages, what we need to do is we need to generate the various groups in Midas Civil. So let's say structure group, I generate structure group 1 to 10. So once I do this, the program will generate the various structure groups. So in a short while, we'll see the purpose of generation of these structure groups. So here I'm specifying the data to different structure groups. So here I will specify the various segments in different structure groups here. Okay, so now as you will see that I have specified the data to the various structure groups. Now what I can do is I can go to the definition of construction staging. So the definition dialog box of construction stage, it can be triggered very easily from this small icon. So as soon as you click on that icon, the construction stages dialog box appears and you can generate the various construction stages. Just to make my task more convenient, instead of adding the construction stage one by one, I'll click on this generate and I'll specify the name of the construction stage, and as soon as I do this, the program will generate the various construction stages. Now I can go to every construction stage one by one and I can modify the data. So in the first construction stage, I've specified the structure group 1, and in the construction stage 2, I've specified the structure group 3. In the construction stage 3, I've specified the structure group 3. So as soon as I'm doing this, the program is generating the construction stages. Now if you want to review the construction stages, you can use this drop-down dialog box. So I'll just click on CS1 and the program will take me to the first construction stage. So here, when I click on CS1, the program has taken me to the first construction stage, then CS2 and 3. Successively, we can create the various structure groups and we can assign them to the particular construction stage. And then after assigning the various elements to the groups and the construction stage, we can activate the structure groups at a specific age. And we can modify the data and we can activate various boundaries. So for the boundaries, we can activate as well as deactivate the various boundaries. Along with that, for the loads, we can activate as well as deactivate various loads. So the purpose of activation and deactivation of loads is that we can activate the loads in various construction stages which are acting on the structure in the construction stage. And for example, if we have the form traveler, so we'll keep on activating the form traveler in the various construction stages, and in the subsequent stages we will keep on deactivating the load due to the form traveler. Since the form traveler will move away, the load should be deactivated, and hence you have an option of deactivating the load in the construction staging. So we can do this. Now if we actually don't want to generate the data one by one using the nodes, elements, and using the various tools of Midas Civil, then what other option that you can use is, so here I will just show that how we can actually generate the bridge very easily using the bridge wizard. So I have just opened a new file, and in this new file I have the definition about the material, and we have the section property for the pier, and we have the tendon property. So now in order to generate the model quite quickly, we can go to this wizard, we can go to balance cantilever bridge wizard, and we can specify the various data. So for example, here the pier table and the key segments, the pier height, everything is specified. And if you want to make a curved bridge, you can specify the radius of curvature of the bridge, and the program will generate the model as specified by you. And once you click OK, the program will generate the entire data for you. It will generate the model, node elements, and it will generate the tendon profiles. It is also going to generate the construction stages for you. So here if you see that for CS1 we have the pier and the pier sections, and then in the subsequent stages the various elements are being activated, and along with that the tendons are also activated. So all this is done by the program using this wizard. So in the wizard we can actually specify the material of the girder, material of the pier, pier section, stage duration, if it is a cast in or precast sections, and then you can specify the pier height and the distance between the piers, and then you can specify the various data regarding the sections. You can create any type of section using this, and then you can specify the various information in the program using the tendon tab. So once you do this, the program will generate this model for you, and it will generate all the construction stages for you, and even the load for the form traveler will be generated. So for example, here if you will see that in construction stage 7, the form traveler load is applied on the last segment, and as soon as I move to the next stage, which is CS8, the form traveler load is deactivated from the second last segment and activated at the most recent segment. So like this, the program will actually complete the entire model for you, and CS16 will be the stitching of the segments, and this is the base stage, which includes the entire information about the entire model. So here we have the entire model with us, and after generating the construction stages, we will actually move to generation of some moving load data. So we will see that how we can actually generate the moving load data for a curved bridge. So here we have this curved bridge, and in order to generate the moving load data, we can go to the tab called load, and in the load we have this moving load option, and in the moving load we have the various options. We have Eurocode and we have the BS code. So we can use either of the two options, either BS or Eurocode. So there is no problem in that. So there is a 4-step process for generating the moving load. The first step is the selection of the code. If we want to generate the moving load as per the BS or the Eurocode. So here I've specified BS code, and the second step is definition of the traffic line lanes. We need to specify that where will the vehicles be moving. So in order to do that, we can specify the eccentricity, and we can select that the vehicles will be moving on these elements. So as soon as I click add, the lane will be generated. So here you can see that the lane is generated, and you can even see it in the model view. So here we have various dots representing the moving lane. So the center line represents, the arrowhead represents the center line of the lane, and then two edges represent the wheel spacing, and the last two dots represent the lane width. And similarly, we will generate the second lane, and in order to generate the second lane, we'll specify the eccentricity, and as soon as I click apply, the second lane will be generated. I'll just change the naming of the lanes. By mistake I specified lane 2 and lane 3. I'll change it to lane 1 and lane 2. So here I've generated the lanes, and if you want to see, you can right click on the work tree and you can click on display. So here we can see both the lanes. So the generation of the lanes is a second step in the generation of the moving load data, and we can generate the lanes very easily for the straight or for the curved bridges. So both are equally easy. And the third step in the generation of the moving load is the generation of the vehicles. So the program provides the database of various vehicles, HA, HP, and HA and HP combined. So here we will use HA and HP combined, and once I click OK, the moving load data will be added, the vehicle will be added, and we can see the entire data in the worktree here. And the last step in the generation of the moving load is the generation of the moving load case. So we just need to combine the vehicles with the specific lanes. So I've specified the moving load case, and when I click on add, I can choose the two lanes on which the vehicle will be moving. Close. So here, using this, we can actually generate the data quite easily, and if I select the Eurocode, you will see that we can actually add the Eurocode vehicles quite easily. So here we have the various vehicles as per Eurocode, LM1, LM2, LM3, and LM4. Eurocode demands various permutation and combination of vehicles, where the vehicles will be straddling between the various lanes, among the various lanes. So Midas Civil is able to generate all these permutation combinations automatically, so that you don't need to spend a lot of time in deciding the most critical positioning of the vehicle. When it comes to the positioning of the vehicle, sometimes engineers spend a lot of time in deciding the most critical position of the vehicle, but in Midas Civil, we don't need to do this task manually. The program can actually decide the most critical position of any given vehicle on any given lane, and it can give you the most critical results. Doesn't matter if it is a stick model or a grillage model. The program is capable of dealing with both of them using the beam elements as well as using the plate elements. So you can apply the moving load quite easily. And the results of the moving load analysis are what actually save your quite a lot of time. So here we have generated the moving load. And similarly, if you want to generate the temperature load, then you can specify the temperature gradient or the beam section temperature quite easily. So you can specify the temperature data and the program will take care of the temperature loadings by itself. And in a meanwhile, in a short while, we'll see the results of the analysis. So we'll see that what are the various results for the construction stage analysis in Midas Civil. We will see the camber results and the various diagrams for each and every construction stage. We will see stresses, bending moment diagrams, and deformations for the various construction stages. So the results, they are available in the form of graphic as well as in the form of tables. And for the tendons, especially the time-dependent loss graph is available. And all these results are generated by the software. So now let's go back to the software and see that how we can actually generate the results, how we can analyze the model and get the results. So in this model, we don't have creep and shrinkage. So I'll just specify the creep and shrinkage quite quickly so that it is taken care while the model is analyzed. So I'll change the units back to Newton and mm, and as soon as I click on creep shrinkage and click add, so I can check the results. And similarly for the compressive strength, I will add the CBFIP model, and then I will link these two models with the material data. So once I do this and click add, I've completed my assignment of the materials and the properties. So the next step we can do is we can straight away analyze this model. So once I click on analysis, the program will run the analysis. It will run the analysis for the construction sequences as well as the post-construction sequence. So we'll see that what type of results are available in the program. So I would like to repeat that the moving load analysis in Midas Civil is available as per British standard as well as European standards. And AASHTO standards are also available, but we expect most of the countries participating in this webinar to use the British standard or the Euro standards. So both these standards are available, and the method of working with both standards is same. So if you are capable of working with the British standards, then you can work with the Euro standards in the same way. So in order to save the time, I'll open a completed model in which I've already analyzed this particular model. So I'm opening a model and we'll see the results in that particular model. This is just to save the time, and we'll see that how we can actually perform the section capacity check, how we can check the section for flexure, shear, torsion, and the various serviceability limit states. So we'll perform all of this in this model. So basically these two models are similar models, and in this model the analysis is completed. So first let's look at the results of the construction stage. So the first thing is that if you want to see the results of any construction stage, you can directly go to that particular construction stage. So for example, you want to see the construction stage results pertaining to CS8, you can just go to CS8, and then in the results tab you can go to the forces, or if you want to see the deformations, you can go to the deformations and you can click apply. So now let's see that what results are available and how do we interpret these results. So here we have this. So the first thing is that you can actually see the results for the dead load. So for this CS8, we can see the results for the dead load, and we can see the results for tendon primary. We can see the results for creep primary and summation. So we can see all the results for various load cases, and for each and every construction stage we can actually see these results. Along with that, Midas Civil provides you to study the current step displacements. Now when we are actually going through a construction stage and we want to see the results at any construction stage, then we have two options. We can either see the accumulated displacements. So let's say if we want to see the displacements in this particular element in CS13, then we can see the accumulated displacements in this particular element, or we can see the current step displacements, the displacement that happened only in this particular stage. So if we check on the current step displacement, we will see the current step displacement, but if we check off this option, we will see the accumulated displacements till that particular stage. So the program provides this option, and you can see the results with a legend. So here you can generate a legend and you can see the values in the legend. And for the beam diagrams, you can switch to the next tab, the forces tab, and you can generate the beam diagrams. So here you can see the bending moment about the major axis, and I usually prefer to see it with a solid fill. And you can switch any of the load case and you will readily see the results for that particular load case. So due to all the loads, you can actually see the effect coming on the piers as well. So if I start checking Fx, which is the axial force, you can see the axial force in the pier for any particular stage. So any axial force developing in the girder as well as the pier, you can study it, and even the shear results are available. So you have all these results available for the construction stages, and you can even generate these results in the form of a table. So for example, if you want to generate the dead load results for a particular construction stage, then you can choose that stage and click OK. Once you click OK, you will be able to see the results in the form of spreadsheets. And if you want to export these results in spreadsheets, you can click on Export to Excel. And the another option is if you want to generate the graph for these particular forces, you can click on the Show Graph and you can see the results in the form of a graph. So all these options are available. Now talking about the tendons. So for the tendons, what you can do is you can go to the result tables, and there in the option tendon, you can click on various options. So you can click on tendon coordinates or tendon elongation or tendon arrangement or the tendon loss. So if you want to see the tendon loss, you can choose the particular tendon group and you can choose the stage in which you want to see the results. So if I move to OCS and I go to tendon and tendon loss, so here you can see that the results are available for the tendons in the form of stress as well as in the term of forces. So here you can see that the results you can see for the various tendon groups that we have used, and you can see the force in the tendon after the immediate loss, and then you can see the elastic deformation loss, and you can see the ratio of elastic loss by immediate loss, and then you can see the creep shrinkage loss, you can see the relaxation loss, and you can see the ratio of force after all the losses and after immediate loss. So all these results are available in the form of Excel, and if you want to see these results in the form of a graph, you can click on the tendon loss graph and you can generate the tendon loss graph by clicking the particular tendon group and choosing the particular construction sequence. So these results are available in the software. So now talking about the results of the moving load analysis, this is something which I see almost every day, that engineers save quite a lot of time when they're actually using the moving load analysis in Midas Civil. So if you want to perform the moving load analysis on this page, you can define the data, and when it comes to the results, usually what we do is that we actually generate the influence lines using the software. We define the vehicles and we generate the influence line using the software. Then we position the vehicle manually on that using those influence lines. We decide the most critical position of the vehicle manually, but this is not something which is required in Midas Civil. So in Midas Civil, the results of the moving load analysis are available directly. So for example, if you want to see that what is the maximum bending moment for the moving load case for this element, so my is the bending moment and for this particular element. So if you want to see that what is the maximum bending moment for this element under all the possible positions of the moving load, then you can just choose it and you can click apply. When you click apply, the program will show you the maximum value of the bending moment. Not only that, the program will also show you the position of the vehicle. So once you click OK, the program will show you the position of the vehicle for which case that particular effect is generated. So if you see this particular vehicle, particular element, you can see that under what position of the loading the most critical effect has been generated. So you can choose any of the components and you can choose any of the elements, and the program will show you the entire result. It will show you the value of the maximum moment as well as the position of the vehicle. Now after this, I would like to explain about the concurrent forces. Now when it comes to the design, actually we cannot design for the maximum effects. We cannot design for maximum bending moment. We cannot design for the maximum shear force, because all these effects, they are not going to occur simultaneously. So this poses a great challenge among us, that how do we actually extract the concurrent forces from the software so that we can have a very optimized design. So in order to do that, we can go to analysis and we can choose the moving load, and here before performing the analysis we can specify normal plus concurrent forces. So if we choose this normal plus concurrent, then program will also calculate the concurrent forces. When the bending moment is maximum in a particular element, then what are the corresponding shear forces and the axial forces. So you can get those results in Midas Civil if you click on normal plus concurrent forces. And before I move to the design part, the last thing that I want to discuss in the results part is the camber control. So the camber results are a very big subject for the segmental bridges. So in order to obtain the camber results for any type of bridge, Midas provides various camber controls. And so for this bridge, we can actually specify the camber control. We can specify the bridge girder element group, support node group, and the key segment element group. And once I go to the FCM camber, FCM stands for free cantilever method and also the balanced cantilever method. And you can then see the camber in the form of a graph. You can get the camber values in the form of a graph as well as in the form of a table. Both the options are supported by Midas 7, and you can see that just by one click you can actually get the accurate camber control. And in case you are using the precast segments, you can get the manufacturing camber as well, and you can get the construction camber. So the program supports the manufacturing camber as well as the construction camber. In case of precast segments, you can get the manufacturing camber as well along with the construction camber. So these are the results provided by Midas Civil. Now before I move to the last part of the presentation about the design, that how do we actually check the section capacity, I would just like to remind that if you have any questions, you can write down the questions in the questions window. I'll be taking all the questions at the end of the presentation. There are a lot of questions in the questions window already, but if you have more questions, then please feel free to write the questions in the questions window. So here we'll do this, that we'll go to the design tab and we'll see that how we can actually perform the section capacity check, how we can check that the pre-stress is sufficient or not, how we can check that is the reinforcement sufficient or not, do we need to provide additional pre-stress or the reinforcement for this particular case. So we'll perform the design for this bridge. So we'll see the steps involved in that. First, we should choose the code that we need to use for the section capacity calculation, and then we can choose on the parameters. So we can specify the parameters that we want to use for the section capacity, and then we can specify the design data. So we can specify that what is the grade of the rebars and what is the compressive strength of the concrete that we are using, and then we can specify the design position. So the reason that we have this option in Midas Civil is that we can specify certain elements to be designed. If we don't want the entire bridge to be designed at once, we can just specify particular elements in the position for PSC design, and the program will design only those specific elements. The program will check the capacity of only those specific sections. So here we can generate that, and then moving to the design part, here we have the PSC design option. So as soon as I click perform design, the program will start performing the design. In order to save the time, I've just used the first 7 elements in order to perform the design. So we'll see that how we can actually perform the design. So as soon as I click on perform design, the program will calculate the capacity of the sections, and it is also going to calculate the required force across all the construction stages and all the service requirements. So we'll see that how we can actually generate the report after this and what are the various options available for us for the generation of the PSC design. So the program is generating the design, and once the design is completed, we'll get a notification that the generation of PSC design has been successfully completed. So if we want to see the results, we have a couple of options. The first and very useful option for generation of the design to see the design which is preferred by a lot of engineers is this PSC result diagram. In the PSC result diagram, you can see the capacity as well as the required force at once. Usually I prefer the solid fill, and as soon as I click OK, you will be able to see the required force as well as the capacity of the sections. So here this green line, this green diagram on the section, it indicates the capacity of the section. So here you can see that for the various sections the capacity is indicated, and similarly for the same sections the required force is also indicated. So we can directly see that the required force is lower than the capacity, so we don't need to provide additional prestress or the additional reinforcement. The provided rebar and the provided reinforcement is sufficient. So we can see the results in the form of a PSA result diagram, and we can get the various results in the form of a table. So here you can see that if you want to see the flexure strength in the form of a table, you can generate it. And in the form of a table, you can see the moment capacity as well as the moment requirement, and you can see the steel area. So here you can see all the results in the form of a table. And if you want to see, you can also see the shear strength check in the form of a table. So here you can see the required shear. So you can see the shear capacity as well as the shear force, and if it is okay or not. If something is insufficient, it will be highlighted with the red color, and you can see the combined shear and the torsion strength check as well. So all these results, they are available in the form of an Excel. And similarly, if you want to see the serviceability checks, you can check the serviceability checks. So for example, principal stress at construction stage, you can generate the results in the form of a table. So here you will be able to see that some elements are failing in this particular check. So it means that we need to revise the pre-stress or the reinforcement. And you can even see the you can even check the stress for cross section at the service loads, and you can check the tensile stress for pre-stressing tendons, that how the pre-stressing tendons, how the stress in them is varying in the various construction stages, and if it is allowed by the code or not. So we have these various options, and along with that, uh, one of the important things that I wanted to mention in my presentation is about the shear lag. So if we are actually using the Eurocode, then the program is capable of calculating the effective width scale factor automatically by itself. So the program will calculate the effective width scale factor by itself, and it will take care of the shear lag effect in the box girder. Now let's have a look at the what type of design reports are actually generated by the software. So in order to generate the design reports, I can click on the Excel report and the program will generate the design report for us. Or in order to save the time, I can open one of the pre-generated design report. So the program actually generates this type of design report where you have the element number and element position. Then you have the design condition, that what are the various design situations for which the design is carried out and in what specification of the Eurocode this is specified. And then you have the cross-section information with the cross-section diagram. And then you have the information about the material, that how is the allowable stress calculated from the Eurocode. And then you have the tendon profile data, and then you have the calculation of the positive moments. One of the things which is really appreciated by the users of Midas Civil, or which is very useful for them, is regarding the calculation equations. So here you will see that when program is actually calculating any of the parameters as per the Eurocode, the program is giving you the complete equation, not only the result, but the complete equation is mentioned, and along with that, the specification number of the code is also mentioned. So for example, this particular equation is coming from this specification of the Eurocode, and if you want to cross verify, you can just go to the code and you can see the specification in the code. And similarly, the positive and the negative moments, the checks are specified, and the maximum shear force, so the calculation of shear force is specified using the equations, and everything is referred to with the code specification. So for example, the check for the minimum shear reinforcement, the specification number is mentioned and all the equations are listed that using which calculation the parameters are calculated. So it provides a very transparent solution to our design problems. So here you can see that all the results, they are available, and very comprehensive design result is available, and this is the report generated from the software directly. No editing have been made in this report. So all the tendon results are available in the form of a table as well. So while the program is still generating the report, so we have already seen the report from the previous project. So I can click on stop execution just to save the time. And after that, one advantage of Midas Civil is that it provides you an option to perform the PSC design as well as the steel design. So for example, if you want to calculate, if you want to design the RC piers, you can just click on the RC design and you can perform the column design straight away. You don't need to export the forces to any third-party software, or you don't need to perform any other specific check for the RC sections. In the software itself, you can directly perform the RC design. So if you have other elements, if you want to perform the design for the transverse tendons, you can even incorporate the transverse tendons in the model and you can perform the design for them. So now, before I move to the end of the presentation, I would just like to mention that what type of sections can be designed in Midas Civil. So in order to give you an idea about what type of sections can be designed in Midas Civil, so if we want to perform the PSC design of the sections, then we can actually perform the design for any sort of PSC section, any shape of the PSC section. There is no requirement of a particular shape. So you can see that for the various shapes, we can perform the PSC design straight away. And the procedure is similar to what we have seen today, and even the results are similar to what we have seen today. And you can perform the design for the composite sections. If you have U girders, I girders, T girders, then you can perform the design for sections, for those sections in Midas Civil. And similarly for the steel composite bridges, you can perform the design in the similar manner that we have discussed today, and you can perform the RC as well as steel design like I've presented today. And yeah, so this was all regarding my today's presentation. So if you have any questions, you can write down the questions in the questions window. And if you want to see any particular feature or any particular situation you have that you want me to demonstrate, then please write down all your questions in the questions window. I'll take the questions in a while. So before I move to the Q&A, I would once again like to mention about this special promotion that we are having on Midas Civil these days. So everything that we have actually seen today is actually included in this version of the software. You can use the time-dependent material effects as per CBFIP, Eurocode, Australian as well as American standards. Then you have the moving load analysis as per all these codes, and various type of linear as well as nonlinear seismic analysis can be performed. And for the PSC design, the various standards are supported, and Midas Civil can be used very successfully for the conventional bridges like box culvert frame bridges, and it can be used for girder bridges, U-girder, I-girder, T-girder bridges, and steel girder bridges, and it can also be used for segmental bridges. In segmental bridges, you can do balanced cantilever, movable scaffolding, and full shoring method. And as per the discount, so the discounted price of the software is mentioned in this offer on the computer screens, and it actually includes all the options that we have seen today, and indeed our sales team is willing to pay special attention to all the requirements that you might have in addition to this. And regarding the users in Asia Pacific, so in Singapore we have Land Transport Authority of Singapore and T-Violin and CPG using Midas Civil quite successfully, and we have a lot of other companies as well. And along with that, in Hong Kong we have Oricon, ACOM, Arab, all using Midas Civil, and in Australia we have a couple of other companies like SMEC, Hyder, Jacobs, and they're using Midas Civil as their main bridge analysis and design tool. Along with that, in Malaysia, Midas Civil is a widely accepted software and widely used software, and the companies like JKR and DBKL, they're also using Midas Civil as one of their main tools for bridge analysis and design. So if you have any questions, you can write down the questions in the questions window. I'll be taking up the questions in a while. So I'll close the project. And if you want to see some of the project applications done using Midas Civil, then I would like to take you to this particular slide. So here you will see that what type of various bridges can be done using Midas Civil. And these are the actual project applications from some of the engineers who have been using Midas Civil. So here you will see that the various types of bridges, they can be done quite easily using Midas Civil. So if you have balanced cantilever bridges, you have girder bridges, and you have cable stayed bridges and suspension bridges and steel girder bridges, steel composite girder bridges. Then all these bridges can be done quite easily and quite quickly using Midas Civil, and various foot bridges, dynamic analysis for foot bridges, and integral bridge analysis, they are all available in Midas Civil. And steel bridges can also be done in Midas Civil. So if you have a steel bridge, steel arc bridge, then you can do it in Midas Civil. And the various linear as well as non-linear analysis are available. And Midas Civil is a general purpose 3D FEM software, so it can be used not only for bridges but also for the various other type of structures. If you're doing some subway stations or any other type of structure, you can actually use Midas Civil quite easily for any type of structure. So I'll be taking the questions now. If you have any questions, please write down the questions in a questions window. Once again, thank you for joining today's webinar.